Here the problem related to the trapezoidal dam structures. Okay, the given problem is a trapezoidal masonry dam is of 18-meter height. So the given data becomes, so masonry dam height. So they have mentioned the capital H is equal to 18 meter. The dam is having water up to a depth of 15 meter. So water depth small h is equal to 15 meter, and water is at dam's vertical side. Okay. Next to that, the top and bottom with the A and B. A value is 4 meter and B value is 8 meter respectively. And they have given that omega naught is equal to 19.62 kilonewton per meter cube. Okay. So that we have to assume that omega is equal to, that is density of water is equal to 9.81 kilonewton per meter cube. Okay. Now find out the first question, the resultant force on the dam per meter length, that is R value. Second one, the point where the resultant cuts the base, that is X value. Next, the maximum and minimum stresses, intensities at the base. So sigma max, comma, sigma minimum value is equal to how much, that they are asking. Okay, let us move on to the problem, that is solution part. So first of all, I will draw the diagram first for ease of understanding. So the A value is equal to 4 meter and the B value is equal to 8 meter. So total H 18 meter on the water level. Small h to the base is equal to 15 meter. Okay. Now A, B, C and D. So this is G. So that W is acting here. This is N. And here the force F is acting. So this height is H by 3. The resultant will going to act somewhere here. So this is R. Okay. So this place is nothing but M. So the distance between N to M is equal to X, and from A to M is equal to D. Okay. Now we have to calculate the things which are related to this. Okay. So if it is H by 3, then it becomes 5 meter. Okay. So first, force due to water. Force due to water, that is F. Density into area into H bar. So the formula is nothing but density into H squared by 2. Okay. So 9.81 into 10 to the power 3 into 15 divided by 2, H squared by 2. So it becomes 9810. 1103625 newtons F value. Next is second force, that is weight of the dam. Weight of the dam. So W is equal to not into A plus B divided by 2 into H. Then it becomes 19.62 into 10 to the power 3 multiplied with 4 plus 8 divided by 2 into 18. So the value of W becomes 2 2118960 newtons. So this is the value of W. Okay. Now we need the distance AN. Okay. So what is the distance AN? Actually, first of all, we need the resultant force. Okay. The first question is the resultant force R. So R is equal to root under F squared plus W squared. So root under F squared plus root under W squared becomes, that is 1103,625 squared plus 211,8960 squared. Then the resultant value becomes 2389137.8 newtons. So which is nothing but R is equal to 2.389 mega Newton. So this is the value of R. Next one, we need the centroidal distance. That is not a centroidal distance. We need the distance of X where the resultant cuts the base. Okay. So before that, we will calculate the value of AN. Okay, the value of AN is equal to how much? From here to here is equal to how much? That we have to calculate it. So for that, to calculate the value of AN, that is the distance of AN, have to equate the area of the section about its face AC. So rectangular portion area. Okay, so rectangular area multiplied with centroidal distance plus triangle area multiplied with centroid distance is equal to trapezoidal area multiplied with centroid. Okay, so rectangular area, so 4 into total height 18 multiplied with centroid 4 by 2 plus triangular area. So 8 minus 4, that is the base distance, okay, half BH. So half into 8 minus 4 into height 18. So area available multiplied with the centroidal distance. So here the centroidal distance is nothing but the base length A plus 1/3 of B minus A. So 1/3 of B minus A. That is B is 8 minus A 4. So total trapezoidal area A plus B, that is 4 plus 8 divided by 2 multiplied with the total height h. So structure height h is equal to 18 meter multiplied with the centroid distance an. Therefore an is equal to how much? We can calculate. Okay. So here 4 into 18, 4 into 18 into 2, 144 plus half into BH, 4 into 18 into 4 plus 4 by 3, 192, which is equal to 6 into 18, 108 into an, which implies an is equal to 144 plus 192 divided by 108. It becomes 3.11 meter. So an, the distance an is equal to 3.11 meters. The other formula to find the an, another formula to find an is equal to a squared plus ab plus b squared divided by 3 into a plus b. So if I am going to substitute 4 squared plus 4 into 8 plus 8 squared, the whole divided by 3 into a plus b total. So it becomes 3.111 meters. This an value. So in both the things, the same value we got. Okay. Now let us move on to the second question. That is the point where the resultant cuts the base. Okay. So x value we have to find out. So x value we know that f by w into h by 3 is the formula. So f value is 1103625. 1103625. W value is 2118960. 2118960 multiplied with h by 3. So small h divided by 3. So 1103625 divided by 8. So it becomes 2.604. Okay, 2.604 meters. So this is the value of x. So the third question, the maximum and minimum stresses at the base. So sigma max is equal to W by B plus 6 into W into E divided by B squared. Similarly, sigma minimum is equal to W by B minus 6 into W into E divided by B squared. So W we know that 211 89620. Am I correct? Sorry. 8960 newtons. B is equal to 4 meter. Okay. So remaining only one thing, E equal to how much, that we have to calculate. So we all know that one formula, E is equal to D minus B by 2. Okay. Whereas D is equal to AN plus NM, we know that. Okay. From the diagram. So D minus, sorry, AN plus NM, then D minus B by 2. So B by 2 is nothing but nearly the centroid, B by 2. Okay, so that we are going to. So here triangle and rectangular have the base width as same, that is 4 meter, 4 meter. So that's why it won't change, B by 2. Okay. So D is equal to AN plus AM. So AN value is 3.11 meter. So 3.11 meter plus NM is nothing but our X value. So NM is equal to nothing but our X value. So 2.604. So by adding this 3.111 plus 2.604, it becomes 5.715 meters. 5.715 meters, the value of D. Therefore, E becomes 5.715 minus B by 2. So B equal to 8 meter. B is equal to 8 meter divided by 2 minus 4. So it becomes 1.715 meters. Okay. Therefore, sigma max is equal to divided by B 8 meter plus 6 into 2118960 into eccentricity 1.715 meters divided by B square. Similarly, sigma minimum is equal to 2118960 divided by 8 minus 6 into 2118960 5 by 8 square. So 2118960 divided by 8 plus 6 into 2118960 multiplied with 1.715 divided by 8 square. So that our sigma max value is equal to 60,559.03 Newton per meter square. Sigma max. Similarly, sigma minimum value is equal to minus 75819.0 Newton per meter square. So this is compressive stress and this is tensile stress, that is sigma minimum is equal to 75819 Newton per meter square. This is tensile stress. So this is the answer for our first question. So the given problem is this. For that, corresponding to their answer is sigma maximum is equal to some 60,559.03 Newton per meter square compressive, and sigma minimum is equal to 75819 Newton per meter square tensile stress. Okay.